Hi everyone! Here we have lesson 7.5, division property of exponents. We haven't done anything with division yet, so here we're going to take a look at how can I divide exponents. And remember, the ultimate goal is to be able to simplify expressions with all of these rules. So we're going to look at two rules today. We're going to look at dividing powers with the same base and quotient to a power rule. In order to come up with these rules, I'm going to take a look at some examples and see if you can notice any patterns. So let's take a look at the first one. You see we have a fraction bar. We know that that means to divide. I'm going to expand this and see what you can tell me. I have 2 to the 6th power divided by 2 to the 2nd power. Notice the bases are the same. You can divide powers with the same base. Let's see what happens. I can write 2 to the 6th power as this. And I can write 2 to the 2nd power as 2 times 2. Now, you know that 2 divided by 2 is 1. That cancels out. 2 divided by 2 again is 1. Now let's see what I have left. 2 times 2 times 2 times 2. That could be written as 2 to the 4th power. Done. Let's look at the next one. Here I'm dividing powers with the same base. I'm going to write it out. X to the 7th. Looks like that. And x to the 5th. Now, we know that x divided by x is 1, and they cancel out. Cancel, 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 and cancel. What do I have left? X times x, which is x squared. Now, what are you noticing? When I divide powers with the same base, what can I do with the exponent? Again, what can I do with the exponent? Do you see it? You're right. 6 minus 2 is 4. And 7 minus 5 is 2. You subtract. You subtract the top minus the bottom. So a quick way to divide powers with the same base is to subtract the exponents, and the base would stay the same, x and x. So let's write it down here. To divide powers with the same base, subtract the exponents. All right, there's our first rule. That's easy. Now let's take a look at this one. It says quotient to a power. The reason why this is called a quotient to a power is because this inside the parentheses says 1 divided by 2. It's a quotient, dividing two numbers. You'd probably see it as the fraction 1/2 though. We're going to take this entire fraction 1/2, or the entire quotient 1 divided by 2, and raise it to the 4th power. Now you know that that means this. All right, now let's take a look and see what we have. 1 times 1 times 1 times 1 is 1 to the 4th power. And 2 times 2 times 2 times 2 is also here 2 to the 4th power. Now, of course, I can simplify this, but this is what I want you to notice. Do you see in the numerator 1 to the 4th power? The top number here, the numerator, had to go up to the 4th power. But the denominator also had to be brought to the 4th power. See this number down here? It also had to go to the 4th power. Everything in the parentheses shoots up to the 4th power. And of course, in some cases, I could simplify this. And this is one of those cases. Let's try this one down here. Now I have this quotient, and I want to raise it to the 3rd power. That means I'm going to take this quotient and multiply it by itself 3 times. All right. If you notice here, I have x times x times x. I have the same base, right? And I'm multiplying. We know that we can add the exponents. I mean, you know this is x times x times x times x times x times x. Well, that would be x to the 6th. And then, down here, y times y times y would be y to the 3rd. And that's as simple as I can get. Now let's see what happened. Do you see how I had to take the numerator? It already had a power, and I had to raise it to the 3rd power. Power to a power, I multiply the power, so I get 6. But not only did I have to take the numerator up to the 3rd power, the denominator also had to go up to the 3rd power. Do you see that? Y to the 3rd power. So with a quotient to a power, everything inside the parentheses has to be brought up to that power. So to raise a quotient to a power, I raise both the, you guessed it, numerator and denominator to the power. And in some cases, simplify. Well, there we go. We have both of the exponent rules for division. Dividing powers with the same base, subtract the exponents. If it's written as a fraction or a quotient, everything goes up to the power that's in the parentheses. Let's give it a try. Our first examples, we're going to take a look at using the dividing powers with the same base rule. Here's my expression. Do you see here how I have a fraction in front? 12/15. I can divide a 12/15 because I can divide both 12 and 15, sorry, by a common factor, which is 3. And so do you see the negative out in front here? This would be negative, you guessed it, 4/5. Now let's look at the exponents. I have c to the 12th divided by c to the 9th. When I'm dividing powers with the same base, I subtract the exponents. 12 minus 9. And the answer goes upstairs, always. So answer, upstairs. Now if I take a look at my answer here, I don't really have any more simplifying to do. I have negative 4/5 with a c to the 3rd power up on the top. There's my final solution. Okay, I just simplified the numbers out in front, and then I subtracted the exponents. Let's try this one. Do you see the numbers out in front make a fraction, 49/21? Can you simplify the fraction? Yep, and to simplify fractions, you divide by a common factor, 7. Okay, so that's going to give us 7 up here and 3 down here. Now let's look at the exponents. The a's, I'm dividing powers with the same base, so subtract the exponents, top minus bottom. 4 minus 6 is negative 2, and the answer goes upstairs. Let's do b. Dividing, so I subtract the exponents. 7 subtract negative 2. Do you see how that's adding? You're right, I get b to the 9th, and the answer goes upstairs. Okay, last one here. If I'm dividing powers with the same base, I subtract the exponents. Negative 3 subtract negative 5. Negative 3 subtract negative 5. Do you see how that's adding here? And you get 2, and the answer goes upstairs. Okay? Now, if you notice here that I do have a negative exponent, this one is going to have to come downstairs. So let's rewrite our answer. 7/3. B and C stay up top, but the A comes downstairs and becomes positive. And there I have my simplified answer. All of this simplified right here. Okay, so this was just using the dividing powers with the same base rule, right? We divide powers, we subtract the exponents. And if there's any fraction, we want to simplify that like we normally would, by dividing by a common factor. Now let's take a look at a couple examples that involve a quotient to a power. Okay, so remember with this, everything inside of the parentheses is going to have to shoot up to the 3rd power, the entire quotient or fraction. All right, so we have the w. It's to the 5th power, and we want to raise it to the 3rd power. So we have a power raised to another power. Power to a power, do you remember what we do? Multiply the powers. Now the denominator is a 4, and we have to raise it to the 3rd power. So here we have 4 to the 3rd power. We need to keep simplifying because we can change this into a number. W to the 15th, and 4 times 4 times 4 is 64. And there we go. We've taken this expression and we can simplify it right here to this. Let's try number 4, and feel free to pause the video if you want to give it a try, and then you can play it and see if you get it right. All right, let's take a look at what we have here. Everything inside of this parenthesis set is going to have to go up to the negative 4th power. Do you see in the numerator that there's 2 factors? Both of those factors are going to have to shoot up here to the negative 4th power. 3 to the negative 4th. Remember, don't evaluate that. You can't because of the negative exponent. And then c. Now c already has a power, and we're going up to another power. Power to a power, multiply the powers. Let's go downstairs. Now this d has to shoot up to the negative 4th power also. But do you see it already has a power? So power to a power, multiply the powers. All right, we've got a big problem. Every single term here has a negative exponent. So everything's going to have to switch places. Everything in the top comes downstairs, and everything down here goes upstairs. So D, let's move you up here and give you a positive exponent. C, you're coming down here, positive exponent. Now the 3 is going to come downstairs. Once I put the 3 downstairs, it will have a positive exponent. Now you can evaluate it. 3 times 3 times 3 times 3, which is 81. And that will be down here. And there we have it, our simplified form. We started with this one, and we end up with everything positive exponents and all simplified. In these next two examples, I'm going to take a look at another strategy here with you. Now, you notice here that I have a quotient, or a fraction, and I'm going to raise everything up to the second power. And I could take the numerator to the second power and the denominator. However, do you notice that inside of the parentheses, I can simplify first? It's almost like thinking about PEMDAS. Take a look at the parentheses and see, can you simplify the parentheses first? And you can. Do you see how we're dividing powers with the same base? We can subtract the exponents. So if I subtract 3 minus 10, that's y to the negative 7th power. Then let's bring it to the second power. You remember this exponent? Okay, so all I did was subtract the exponents to simplify it. Now, power to a power, multiply the powers. Okay, you notice we have a negative exponent? So we're going to have to make it a fraction and move it downstairs with a numerator of 1. All done. Now, I know that looks different than what we've done before, but I want to show you that it's the same thing if I were to not simplify inside. If I didn't simplify inside the parentheses, I could take the y up to the second power. Power to a power, I get y to the 6th because I'd have to multiply. Then down here, if I bring this up to the second power, 10 times 2 is y to the 20th. Now notice, if I do this, I have to divide these powers with the same bases, which would be subtracting the exponents. And so 6 minus 20 would be negative 14. And still my answer would end up being the same thing. You see? The only difference here is I simplified inside the problem. You could do it or not. It's just a new strategy. Let's look at number 6. On number 6, you'll also notice that if you look inside the parentheses, you can simplify before we start. It might be a good idea to do that. If we simplify this, I'm going to combine the x's and combine the y's. That way I'm not bringing so many numbers up to the negative 3rd power. So let's try just simplifying everything first. So I'm going to make big parentheses. I'm going to still bring everything to the negative 3rd power. However, I'm going to simplify what I have in here first. So do you see that the 4/6, I can divide top and bottom by 2. And this is going to give me 2/3. Much better. Now the x's. If I divide powers with the same base, I subtract the exponents. 2 minus 4 is negative 2, and the answer goes upstairs. And now the y's. So subtract the exponents here. 6 minus 3, y to the 3rd power, and the answer goes upstairs. Now notice that I have a lot less terms to bring to the negative 3rd power. I'm going to switch colors here. Everything inside the parentheses is going up to the negative 3rd power. Okay, 2, negative 3rd power. X already has a power. Power to a power, multiply. Y already has a power. Power to a power, multiply. Okay, downstairs. 3, it has to shoot up to the negative 3rd power. All right, now take a look and see how we can simplify. You see we've got negative exponents, this one, and this one. You know what to do. If they're upstairs, they come down. If they're downstairs, they go up. The only thing staying is x to the 6th. Okay, let's take this guy, move it down here. It's going to become 2 to the 3rd power, which you know is 8. Y comes downstairs, 9th. Now this comes upstairs. When it goes upstairs, it becomes 3 to the positive 3rd power. 3 times 3 times 3, 27. Now everything has a positive exponent. There's only one x, there's only one y. Everything's simplified. Final answer. All right, we have our last one, number 7. Now we've done something like this before. I'm giving you the area of the rectangle. It's this expression right here. I'm asking you what's the length. So you know the length is the long side. How long is this? Here's the width. Now we all know that to find the area of a rectangle, it's length times width. So length times width equals this area. Now before, what we did was we set up a blank little box, right? What's the length? times the width. So we have length times width equals the area, which is this right here. Now, you could just try and guess and check and plug in what you think this would be. What times 6ab gives us this expression? However, now that we know the division rule, we could do this completely different. We know that length times width multiplied together here gives us the area. But we also know that if we take the area divided by the width, that would give us the length. So we could take the area, 72, A3, B4, and divide it by the width. And that would give us the missing length. You see what I'm doing? So now, let's try it this new way. I got 72 divided by 6. 72 divided by 6, well, it has to be 12 because look at all the answer choices. They all have a 12 in them. Now, a to the third power divided by a to the first power. Subtract the exponents. And then here, b to the fourth divided by b to the first. Subtract the exponents. 4 minus 1 is 3. And there I have my length. Looks like the answer would be B. Now this is a new way of doing it now that you know how to divide. Even if I went back over here and did it the way we did before, I know that 12 times 6 gives you 72. And if I look at the exponents, this is a to the third and this is a to the first. This one would have to be a to the second because when you add the exponents, you get 3. And then for b, this would have to be b to the third because b to the third times b to the first, if I add the exponents, I get 4. So here's my answer if I did it the other way that we learned before, but I could just divide. It's just as easy. All right, there we have it. Lesson 7.5. Have a great day.